What's going on, everybody? Welcome back to my YouTube channel. Look at this nice and beautiful question on the board that we're going to be solving. And the question says, find the value of x and y for which x plus y is equal to 4 and x to the 5 plus y to the 5 is equal to 464. We can call this equation 1 and we call this equation 2. Our first step will be for us to start from equation 2. We're going to be applying a property of x to the 5 plus y to the 5. So what is that property? It is x to the 5 plus y to the 5 is equal to x plus y times. Now, what is inside of this bracket? We start with x to the 4th. I know we're supposed to have y here, but the power of y here is 0, making it 1. So as we go along, the power of x will decrease, while the power of y will increase. So for here, the power of y is 0. Minus, now power of x decrease to 3, then power of y increase to 1. Plus, power of x decreases to 2, power of y increases to 2. Minus, power of x decreases to 1, power of y increases to 3. And lastly, power of x decreases to 0, making it 1, while the power of y increases to 4. So this is a property of x to the 5 plus y to the 5 that we're going to be using. Our next step will be for us to substitute. So x to the 5 plus y to the 5 is given to us to be 464. So this is 464 equal to x plus y is given to us to be 4. So 4 times what we have inside of this bracket. So times x to the 4 minus x cubed y plus x squared y squared minus x y cubed plus y to the 4. Our next step will be for us to divide both sides by 4. So I'll divide the left hand side by 4. I'll also divide the right hand side by 4. So 4 here can cancel off this 4. And 464 divided by 4 is 116. So this is equal to, what I have remaining here is x to the 4th minus x cubed y plus x squared y squared minus xy cubed plus y to the 4th. So let's call this equation 3, since we've already got equation 1 and 2. Our next step will be for us to apply another property. And the property we're going to be applying is x plus y all raised to the 4th. We're going to be using the binomial expansion to expand this. So making use of the Pascal triangle, we have 1, 1, 1. I'm just writing the Pascal's triangle. So 1 plus 1 is 2. Now we end with 1. Remember, we start with 1 and end with 1. So let's go again. Start with 1. Now 1 plus 2 is 3. 2 plus 1 is 3. Then end with 1. This first one here is a power of 0. There's a power of 1. There's a power of 2. There's a power of 3. But I'm looking for a power of 4. So let's do one more. Start with 1. So 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And then end with 1. So what we see here are coefficients. So let's go ahead and expand this. So this is equal to, starting with x. So this is x to the 4th. The coefficient is 1, which is what we have here. So the next coefficient will be 4. So plus coefficient 4. The power of x reduces. to 3, then the power of y increases to 1. Now followed by the next coefficient, plus 6, power of x reduces to 2, power of y increases to 2. Now followed by the next coefficient, 4, so plus 4, power of x reduces to 1, power of y increases to 3. And lastly, the last coefficient is 1, power of x reduces to 0, making it 1, while the power of y increases to 4. So we've been able to expand this using the binomial expansion. I've already got x plus y from the question, and that is equation 1. X plus y is equal to 4. So I'm going to be substituting it here. So this is 4. 4 to the 4 is equal to, this is x to the 4 plus 4x cubed y plus 6x squared y squared plus 4x y cubed, then plus y to the 4th. Let's continue simplifying on the next slide. Alright, so 4 to the 4th is 256. And this is equal to x to the 4th plus 4x cubed y plus 6x squared y squared plus 4x y cubed, and then plus y to the 4th. So we can call this equation 4, since we've already got equation 1, 2, and 3. Our next step will be to solve equation 3 and equation 4. But first off, let's bring them together. Alright, so I just brought equation 3 here. So we are solving equation 3 and equation 4. So our next step will be for us to subtract equation 3 from equation 4. So we are to subtract equation 3 from 4. So let's subtract. So 256 minus 116 is 140. And this is equal to x to the 4th minus x to the 4th is gone. Then 4x cubed y minus making it plus x cubed y, that is 5x cubed y. Then 6x squared y squared minus x squared y squared is plus 5x squared y squared. And then 4xy cubed minus making it plus xy cubed, that is plus 5xy cubed. And then lastly, y to the 4th minus y to the 4th is 0, so no need of writing that. Our next step will be for us to factor out 5, since 5 is common on the right hand side. So we have 140 to be equal to, we don't only have 5 common, 5xy is actually common. So let's factor out 5xy. So 5xy. So 5x cubed y divided by 5xy, I'm going to be having x squared plus 5x squared y squared divided by 5xy, I'm going to be having xy plus 5xy cubed divided by 5xy, I'm going to be having y squared. Let's continue on the next slide. So our next step will be for us to divide both sides by 5. So I'm going to be dividing the left hand side by 5, and I'll also divide the right hand side by 5. So 140 divided by 5, I have 28 to be equal to, now 5 here can cancel off this 5, leaving behind xy times x squared plus xy plus y squared. Well, The expression inside of the bracket is very close to this perfect square, x plus y raised to the power of 2. Well, this expression is equal to x squared plus 2xy plus y squared. So the expression inside of this bracket is very close to this perfect square. Well, the only difference is that I have 2xy here. And in order for me to have xy, I will have to remove xy from 2xy. So making this to be the same as this. But remember, whatever I do to the right, I'll also do to the left. So I'll have to remove xy from here as well. So that means instead of working with this, I can go ahead and replace this with this. So this becomes 28 to be equal to xy times, remember, I'm going to be replacing this with this. So times x plus y all squared minus xy. Cool. Our next step will be for us to substitute x plus y. Remember, x plus y from equation 1 is 4. So this becomes 28 equal to xy times, so x plus y is 4, and I'm going to be squaring that, minus xy. So this simplifies into 28 equal to xy times, now 4 squared is 16 minus xy. Our next step will be for us to open up the bracket so that we have 28 to be equal to xy times 16 is 16xy minus, now xy times xy is xy raised to the power of 2. Our next step will be for us to rearrange this expression, since this expression is a quadratic equation in xy. So let's rearrange by moving everything on the right hand side to the left hand side. So starting with this, so when negative xy all squared move to the left, it becomes xy all squared positive. Now when 16xy moves to the left, it becomes minus 16xy. I've already got plus 28 here, and this is equal to 0. Now, what are the factors of 28 that we can use to factorize this quadratic equation? We have negative 2 times negative 14. So negative 2 times negative 14 gives 28. And when you add them, negative 2 plus negative 14 give negative 16. So we can use this. So this quadratic equation factorized into xy minus 2 times xy minus 14. And this is equal to 0. Now, using the 0 product rule, we have xy minus 2 to be equal to 0, or xy minus 14 to be equal to 0. So for the first one, we have xy to be equal to, as negative 2 crosses to the right and becomes 2. While for the second one, we have xy to be equal to, as negative 14 crosses to the right, it becomes 14. So we have two cases. We have this case where xy is equal to 2, and we have this other case where xy is equal to 14. So we're going to be solving these cases one after the other. So for case 1, so let me start with case 1. Recall that from equation 1 we have x plus y to be equal to 4. That's equation 1. And what we have here in case 1, we have xy to be equal to 2. Let's solve this on the next slide. Now, to solve this, I'll say let xy be x and y rather be the root of the quadratic equation. The quadratic equation. And what is the equation? I'll be writing the equation in t. So this is t squared. Now minus sum of roots. Sum of roots is x plus y, and that is equal to 4. So 4t plus the product of roots. The product of roots is xy and is equal to 2. So this is equal to 0. So we're going to be using the general formula to solve this, which is a quadratic formula. Our a here is the coefficient of t squared, and that's 1. B is the coefficient of t, and that's -4. And c is a constant term, which is equal to 2. So t now becomes the quadratic formula, -b plus or minus the square root of b squared minus 4ac divided by 2a. So let's substitute. We have t to be equal to -b. So -b is -4 plus or minus the square root of b squared, that's -4 squared, minus 4a. A is 1, c is 2, all over 2a, that's 2 times 1. So t simplifies into negative times negative gives positive, so I have 4 plus or minus the square root of -4 squared is 16 minus 4 times 1 times 2 is 4, all over 2 times 1 is 2. So this simplifies into t equal to 4 plus or minus the square root of 16 minus, this is 4 times 1 times 2, making this 8. So 16 minus 8 is 8, all over 2. So t now becomes 4 plus or minus the square root of 8 can be written as the square root of 4 times the square root of 2. I use this because this is a perfect square. So all over 2. So t now becomes 4 plus or minus. Now the square root of 4 is 2, and I have root 2, all over 2. Now let's divide. 4 divided by 2, that's 2. So t becomes 2 plus or minus. Now 2 root 2 divided by 2, I have root 2. So there are two values of t here, which are t equal to 2 plus square root of 2, or t is equal to 2 taking the negative minus the square root of 2. And these are the roots. So which means that value for x and y here is equal to, we can take this first one to be x, 2 plus root 2, and we take the second one to be y, 2 minus root 2. Well, the values of x and y can be interchanged. So y can also be 2 minus root 2. X can also be 2 minus root 2, and y be 2 plus root 2. So this is for the first case. Now let's pay attention to the second case. And we're going to be doing that on the next slide. Now for the second case, let's call that case 2. We're still going to be recalling our first equation, which is equation 1. X plus y is equal to 4. Then for our second case, we have xy to be equal to 14. Like our statement, let x and y be the roots of the quadratic equation. We're still going to be using t, so t squared minus sum of roots. The sum of the root is 4t, then plus product of roots. The product of roots is 14, and this is equal to 0. So from here, a is the coefficient of t squared, which is 1. B is the coefficient of t, which is -4. And c is a constant term, which is 14. Now, we're going to be using the quadratic formula. So t will be equal to -b plus or minus the square root of b squared minus 4ac divided by 2a. Now, let's substitute. So t becomes -b. b is -4 plus or minus the square root of b squared, that's -4 squared, minus 4 times a is 1, times c is 14. Now divide by 2a, that's 2 times a is 1. So t now becomes negative times negative makes positive, so that becomes 4 plus or minus the square root of -4 squared is 16 minus 4 times 1 times 14 is 56. All over 2 times 1 is 2. So t now becomes 4 plus or minus the square root of, now 16 minus 56 is -40. All over 2. So t now becomes 4 plus or minus. Now let's simplify the square root of -40. So this becomes the square root of a perfect square is 4 times the square root of 10. Then since I have negative, I'm still going to multiply by the square root of -1. All over 2. So t now becomes 4 plus or minus the square root of 4 is 2 root 10. Then the square root of -1 is iota, which is I. So times I all over 2. So this is a complex solution. So t now becomes, now let's divide. 4 divided by 2 is 2 plus or minus 2 root 10 times I divided by 2 is root 10 times I. So there are two values for t here. So t is equal to 2 plus the square root of 10 times I, or t is equal to 2. This time, let's take the negative the square root of 10 I. So these are the values for x and y, since x and y are the roots of the equation. So x and y now becomes, let's take the first one for x. So we have 2 plus the square root of 10 times I for x. Then the negative, we take it for y. So we have 2 minus the square root of 10 times I. Then interchangeably, x can also be 2 minus the square root of 10 times I, while y becomes 2 plus the square root of 10 times I. And this is our final solution. So we have 2 real solutions and 2 complex solutions of x and y, which are used interchangeably. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.